My dear friends, welcome back to BSpice. In this session, we'll continue with gas detection technologies, wherein we'll focus on non-dispersive infrared point type. So this is the look and feel of the infrared point type, wherein you can see the IR source, infrared source is directing towards the sapphire window, and again it is getting reflected with a mirror, and it backs to the analytical detector and the reference detector. We will see the detail in the slides, the next slide. Okay, right. So this technology is non-dispersive infrared point type. So it can measure combustible gas, right? So the principle of operation: absorptive IR, infrared, uses gas ability to absorb IR radiation. So that is the principle. So what is happening here? Two gas sample, the gas of interest, what we are going to measure, and an inert reference gas are exposed to the infrared light. Right. So the amount of light transmitted through each sample is compared to determine the concentration of the gas of interest, how much gas is present. So that is the principle. So let's see the detail. So it uses an electrically modulated source of infrared energy and two detectors that convert the infrared energy into electrical signal. So it uses an electrically modulated source of infrared energy and two detectors, that is analytical detector and reference detector, that convert the infrared energy into an electrical signal. So each detector is sensitive to different range of wavelength in the infrared portion of the spectrum. So the source emission is directed through a window, as you can see here, sapphire window, right, in the main enclosure into an open volume, right. A mirror is used at the end of this volume to direct the energy back through the window onto the analytical detectors and the reference detector, right. So the presence of combustible gas will reduce the intensity of the source of emission reaching the analytical detector. Again, I repeat, friends, the presence of combustible gas will reduce the intensity of the source of emission reaching the analytical detector, but not the intensity of emission reaching the reference detector. Okay. So the microprocessor monitors the ratio of these two signals and correlates this into a percentage LEL reading, that is lower explosive limit reading, right? So this is all about the functionality. So of course the reading will get it in percentage LEL, and when we talk about the pros, yes, it is very high accurate and yeah, selectivity, and we can use this for large measurement range, and of course low maintenance is a very good news, and highly resistant to chemical poison. If you look at the previous metal oxide, right, that's subjected to poison, right, but here there is no such things. Highly resistant to chemical poison and does not require oxygen or air, and it is span drift potential virtually eliminated, meaning no routine calibration required. See the beauty of this. And fail safe compared to open path, which we are going to talk about the next slide, next video. It means this point type provides a gas level at the point of detection only. So that is yeah, exact point of detection. Of course that is the principle, isn't it? So it detects at the point of detection only. Yeah. Then when we talk about the limitation, yes, not suitable for measuring gases that do not absorb the infrared. Of course, if the infrared is not absorbed by the gas, then of course it cannot be used, right? And also, some presence of diatomic molecules like oxygen, nitrogen, hydrogen, all the, add to the cons actually. So that's all I have about the non-dispersive infrared point type. See you in the next video, wherein we'll talk about the open path type, infrared open path. Thanks for watching, friends. Take care. Bye bye.